Hello again, it's Mr. Pete, your internet shop teacher. Welcome back, and this is part 3 of a 3-part video on making a hand wheel for the South Bend Shaper. Remember, in the first one I made the match plate pattern. In the second one I cast up the wheel, and in this one I am going to machine the wheel and get it ready to mount on the machine. And the purpose of this, of course, it is 2 inches larger in diameter than the 5-inch wheel, and that gives me extra leverage and it makes it easier to turn the shaper over by hand. So in this video I will be cutting off the sprues and the gates and cleaning this up. There's a lot of flashing on here that I don't like, and I'll be putting it in the lathe and boring it and smoothing it and turning it down. I don't know what all. I want to see how true that it runs, and then drill and tap a hole and mount it on the shaft. So let's go on over to the workbench and get started. This is kind of an irregular casting that's hard to hold in the bandsaw, so I think I'll knock off just the top of these sprues with the handheld bandsaw. I guess I'll have to resort to the Linux. That was no fun. I do believe I want to hold this in the 4-jaw chuck. I'll have to reverse the jaws, but it looks like it's barely going to grip. So that may not work, but for now I want to remove the flashing here, and a lot of that heavy flashing again was caused by what we call elephant footing on the pattern. That's the gate there. I'm going to take some of that off with a big coarse double cut file, but then maybe run it over a little bit on the belt sander and see how smooth I can make that. Now, the original one was flat. It was turned to, in other words, it was cylindrical rather than round. And I don't know yet whether I should try to keep this profile because it is rather pretty, or do I need to just say the heck with it and machine it off flat. Now you can see that's not going to take an awful lot to clean up with a double cut file, a big coarse aggressive file, and a file that is sharp. Throw away the dull files, they will only make you angry. That cleaned up surprisingly well with about 10 minutes of work on the outside. Now I'll use emery cloth and polish that later, but that really took the flashing off of it. Now I got to deal with the inside. I'm not going to show you that, but using again a double cut, coarse, sharp, clean file. The half round there, that's going to take that right off, and the flat right there, and I may have to use a rat tail in the corners a little bit. I'm not sure yet, but be sure and use vise protectors so you don't put vise marks on your project. And I don't know, I don't think I'm going to take those screw heads off because it's honesty in design. The inside ones won't show. That'll be away from you. You never will see that. Again, this will clean off when I have it on the lathe, so I'm not worried about that. So let me do at least one of these and then we'll take a look at it. That's the half round. And then the flat file, or I'll use the flat on that one, for the spokes. And the rat tail in the corner here. Now, I'm not going to spend a lot of time on this because every casting you ever look at will have some flashing there, and you can even see grind marks, so that's no big deal. I'll take a little more off of that and maybe follow up with a single cut file, but look at how smooth that spoke is already. So it just doesn't take much work at all. I've only done that one so far. The rest I'm going to do off camera, but that's not going to take much work. Well, it's the next day and I've switched chucks. I put the forejaw on the closing and I have tentatively set it up in the forejaw, centered it as well as I could by eye, and tapped it in. Now I'm going to put the dial indicator on and take a few minutes and get that set, so it's pretty close. Now I'm going to take the indicator reading off of the hub. I hope that the casting is truly eccentric so that after the hole is drilled and reamed that it will run true. Alright, it took a couple minutes, but I'm within a thousandth or two. The problem with the casting is that this is not a very smooth surface. I probably should put a larger button tip on a steroid indicator, but this is going to be close enough for what we're doing. Always a little fluctuation, like I said, on a casting, but it's running as true as I can get it. I like to lay my cutting tools out ahead of time, make sure I have everything I need. Center drill, 1/4 inch, 19/32. Then I'm going to bore just a little bit to true it up, followed by the 5/8 reamer. I'm going to use one of the solid rock boring bars. All right, let's take it out. Of course, I still have to face this off. Oh, sweet mystery of life. This is a 5/8 shaft. I reamed it 5/8 with 2 different reamers and it still will not quite go on. It will just barely start. I don't want to force it or I'm really in trouble, but if anything with the Starrett mic, I'm reading, well, I am reading about a 1/2,000th over on this shaft. Well, as fate would have it, I just happen to have a whole box full of adjustable and or oversized reamers. So, and there's 2 or 3 of them here that are 5/8. This one was still in the tube. This one, kind of rusty right here. And you know how these work. You just tighten them up a little bit. And to start with, this one falls right through, so that has to be brought up. This one, I don't know where it's set. I did use it recently, but it is set too large. I don't want to go in with that. Also, it's an awful lot of work, believe it or not, even with a big tap wrench on there to open up a hole like this. And it's always a problem when you have a long hole. No big deal if it's just a short piece, short bushing, but the longer it is, the more troublesome it can be. So a fella can waste a half hour or even 2 hours on something like this. Now you can set these reamers with a micrometer, but I'm using an adjustable wrench here and I'm just snugging it up until I feel a little drag. Nothing yet, just a little more. And I'm going to do that, just taking off a little bit at a time. And look, I don't need a tap wrench, that's pretty handy. And then I'll go over and check it out. Be back in a minute. I just went over and tried it, and yes, it does go on, and this is how much I removed. If you can see the shavings on the reamer, just a little bit. But that's just enough to hold it up. These are very nice. Now, if you don't have a complete set and selection of reamers, watch for them and throw away worn ones or damaged ones. But it saves you a lot of work and frustration if you have these adjustable reamers. And I like that kind that I just showed you there so much better than this kind, and I do have a bunch of these as well. These have a greater range, whereas this one actually is a 5/8 adjustable reamer. This one has a range, and it tells what the range of sizes is, and it's very troublesome to use one of these or to adjust it. You know, you might spend a half hour. I still have to drill and tap a set screw, but let's just see how this fits. A drum roll, if you please. See, that goes right on now. Now the question is, will this run true? Fairly true. And look at that. I'm very satisfied. There's minimum run out. I'm sure that it will show some if we put an indicator on it, but just let's remember what this is. I put the wheel back in the 4-jaw chuck so I can face off this end of the hub, and there's still part of the sprue on there. Now, it doesn't really matter if it's held very accurately for this, so I'm going to go ahead and do that, and that can also be done with the work being held on a mandrel. Well, there's a flat on the shaft here for the set screw rather than a keyway, but the problem is that this is just a little bit too long, so I've determined using this hermaphrodite that I need about that distance to locate the set screw, so I have to face off about up to the end of the calipers here. Am I telling you too much? But anyway, I'm going to drill and tap the set screw hole. That'll be 5/16 18 right there, and then I will trim it right here, and I'm going to hold it on a tapered mandrel for that purpose. Now here's a good way to hold that hand wheel in a vise laying on its side, and that's an extra long drill bit so that the chuck will not strike the rim. I won't show the drilling, that's routine. Is everybody happy? Well, I'm not right now. You know, sometimes you run into a problem when you're tapping a hole like this where the tap wrench will interfere with the rim on a pulley or a wheel or something of that nature. That's why they make a product called pulley taps. You see, these are pulley taps. I have a nice selection of many, many more than this as well, but every size but 5/16. But wait, there is a 5/16 18. How nice is that? But many years ago, some moron ground it off to make it into a bottoming tap, so I would never get it started. Well, I did get it started, just a traditional tap, taper tap. But you can see that now the tap wrench is striking the wheel. So what I'm going to do off camera, I will use that other bottoming tap. I think that I've got enough of a start there to finish off with it. The other choice, of course, is to use a little adjustable wrench or something of that nature. But you may run into that problem. That's why I'm pointing that out. Next operation is to face this off. It could be sawed off and even sanded, but I want to do it on a lathe. In order to hold it, you always got to think how you're going to hold it. Well, it could be put back in the 4-jaw chuck, but I like to show you different things too. So this is a lathe mandrel, 5/8 in size, 5/8. So that's the large end. And the other end, which sometimes has a minus on it, is a small end. Well, there's only about 1/1000th difference. There isn't a whole lot. So putting it in from this end, I'm going to press it in just lightly and hold this in the 3-jaw chuck and face that off. a simple operation. Here we go. I do have a carriage stop set. While I still have it set up in the lathe using a file, I want to clean it up just a little bit better than what I did. And a little bit of 80 grit. Let's try it out again. Looks good. Now what I've done here is some layout lines showing where the flat is, and I just wanted to confirm that the set screw will strike the flat flashlight, and it does. So now I can go ahead and put the set screw in. Thank you again, Ted, for making this pattern for me. And I went from a 5-inch wheel to a 7-inch, and I can tell immediately that I have a good grip and it is easier. I got more leverage is what I'm saying, so I'm very satisfied with that. This will not be thrown away. It'll be kept in the drawers. I can always convert it back, or the next owner can, because I do like to keep things authentic as well. Now I still would like to grind these 3 screw heads off. That is ugly, and I want to paint it gray. Other than that, I believe the project is done. Let's see how true it runs. Well, we know it's going to run true. I would have been sick if there was a wobble in it either way, but you can see it's running true as a die. Not a big fan of rotary files in a Dremel, but that's what I'm going to have to do. Ted would be good at this. He's a dentist. Probably loves the sound. Well, then I thought I could clean it up with riffler files, but I only had 2 of them, and they're so fine you could use these for jewelry work, so that's not going to work on aluminum. But the idea is you can come in there at an angle. Now this tool here, this file, I think it's for gunsmiths. I never have used it, but that probably will. Yes, that's how I will finish it off. Well, that looks pretty good. At least that's as good as it's going to get. I don't intend to remove these on the back off, because they're not visible. So I don't worry about that. I have a lot of cleaning up to do around here. I'll degrease this and give it a couple coats of Rust-Oleum smoke gray, which is what I used on the rest of the Shaper. And we'll conclude this video tomorrow, because after all, I smell turkey cooking upstairs. Today is Thanksgiving, and I got to get up there with the guests, 9 or under. I just came out of the basement to do a little bit of research as this video concludes. I went to McMaster Car, and there is a 3-spoke cast iron unmachined wheel in a 7-incher for $28.84. What a bargain. I wouldn't make another one for $500.